let's move on with the Born-Haber cycle. Okay, in the last class I told you that I will tell you what is Madelung constant, but believe me, to my means it's my worst act ever. Told you I will tell in the last video, but I forgot it. So I'm very sorry, and I'm telling you the Madelung constant over here. Madelung constant is a dimensionless quantity, and it is the sum of all the electrostatic interactions of one ion to all other ions. So sum of all the electrostatic interactions of one ion to all other ions. So Madelung's constant is dimensionless quantity. It is the sum of all the electrostatic interactions of one ion over to the all the other ions. Okay, and this is your Madelung's constant, and this is its graph. R not R E. Okay, so this is your Madelung constant. It is a dimensionless quantity, and so this is your Madelung's constant. Now we will check what is Born-Haber cycle. BORN, Born-Haber cycle. So let's check it. Born-Haber cycle. And I would like to say that I am very much simple. I am making the videos very simply, no editing. You can see in a bed I put my copy, my pen, my headphone I'm using, then I'm making the video. So please show some love, like and subscribe my channel so that I can improve the my condition and improve the videos. Now Born-Haber cycle. When a cation and anion interact to form ionic solid and energy is released in this process, this is called lattice energy. Better if I start from the very beginning, that Born-Haber cycle is used to calculate the lattice energy. And what is the lattice energy? When the cation and anion react to form ionic crystal or solid, the energy released in this process is called lattice energy, or the lattice energy is the energy required to form solid ion from two gaseous ions, or of dissociation of gaseous ions from solid components. So either you are forming Na plus Cl minus NaCl, this is uh, energy released in this process is called lattice energy, or you are breaking NaCl into Na plus and Cl minus. This is also your lattice energy. Now we have ionization energy, the energy required to remove an electron from an ionic crystal, electron affinity, the energy released when an electron put into an atom, sublimation energy, the energy required to convert a solid compound into a gaseous state through liquid phase, dissociation energy, the energy required to break an atom, heat of formation, the energy released in the formation of ionic crystals. So now we are forming CaCl2 from CaCl2 reacting to form CaCl2. How you will do this one? See, CaUr delta H sublimation we are doing, so we are getting Ca gaseous. Now over here, ionization energy or ionization potential we are acting, then Ca plus electron minus, ionization enthalpy 2, Ca2 plus electron. From here, if you do delta H dissociation, then you get 2Cl gaseous. Now add electron affinity 2Cl minus. So these two react, you get lattice energy U over here to get CaCl2 solid. Let me show you one more example so that you understand it nicely. Magnesium plus this one. Okay, magnesium oxygen 2, this one, and this is solid. So first you remember, after getting an equation, or maybe the question is written, form MgO by Born-Haber cycle, write the Born-Haber cycle of MgO. This is not written, so you will have to remember how it is happening. Magnesium plus oxygen will give magnesium oxide. Now over here, magnesium is 2 plus, oxygen is 2 minus, you will get MgO. Now your step is to form this Mg2 plus first in this process and oxygen 2 minus in this process, then these two will react. You got this in your mind, do it in the rough. Now you start doing it. You get magnesium solid, so delta H sublimation first you will do to convert it into gas, so magnesium gaseous. Now you do ionization potential 1, so you get Mg plus plus electron. You do ionization potential 2, you get Mg 2 plus plus electron. Now oxygen you dissociate, so delta H dissociation you get oxygen, and delta H dissociation in this you get oxygen as one single oxygen you getting it, and this is gaseous. Now you convert it electron affinity, so you get oxygen minus. You do electron affinity 2, you get oxygen 2 minus. These two go and lattice energy. This is your magnesium oxide bond Haber cycle. Got it? And over here half dissociation, so you are getting one oxygen. This way you can just do it. Okay, okay, everybody understood it? Can I get some comments that yes, I understood it? Okay, in the worst case, if you don't understand this, one more example I will do for you. Let's do it. And then also if you don't understand, you can comment and ask me. Very soon a new video will be uploaded again with the practice. Okay? Bas keep on studying, keep on practicing, doing hard work. Now if it says to you draw the bond Haber cycle of KCl. Okay. Now in bond Haber cycle of KCl, you forget everything that K plus Cl minus. First you remember that potassium and Cl2 will react. Now if I say to you that what you remember in your mind, K plus Cl minus will give KCl. You this recall in your mind. Now you have to form K plus over here. Let's start. Delta is solid, delta H sublimation you will do, so you will get K gaseous. Now you will do ionization potential 1, so you will get K plus plus इलेक्ट्रॉन मिल गया K plus. चलो ionization potential 2 का कोई ज़रूरत नहीं है. Second, over here you will do delta H dissociation, so that you get Cl, which is gas. Delta H dissociation. Now you think of it, you are getting 2 say 1, so obviously half over here you have to calculate. Now you do electron affinity Cl minus, you get chalo hoega. Now this is lattice energy. Okay, understood nicely. This was your bond Haber cycle, nothing more, nothing much. Bond Haber cycle completed. Okay, I will show you one or two more examples like this one. You can do delta H sublimation, you got Ca gaseous. Okay, first you forget this as I said. Okay, CaCl2 will react to give CaCl2, Ca2 plus Cl2 minus you will need, so no need of half dissociation, full dissociation you will do. Here you got Ca2 plus in the same way, electron affinity 2Cl minus you got. Now these two will react to give CaCl2. Understood? Okay, done. You can check one more example. NaCl2 gives NaCl. Cl2 exists in Cl2 form, but we need Na plus and Cl minus. So half dissociation you will do to get Cl gas, electron affinity Cl minus, and delta H sublimation Na gas, Na plus plus electron. These two will react with lattice energy to give NaCl. This is your full bond Haber cycle. Bond Haber cycle notes given, bond Haber cycle definition given, lattice energy what it is said, each term acting on it is said. Now let's look into some numericals. You can write as delta HF, delta heat of formation. Remember all the steps which you did. First you did delta H sublimation, so it will be there. Then you did ionization potential. Then delta ionization H naught. Okay. Then you did delta H dissociation. Then you did electron affinity is minus, so minus delta H electron affinity. Delta electron affinity. Delta dissociation H naught, delta electron affinity H naught, delta ionization enthalpy H naught, delta H sublimation. Okay. Anything more you did? Plus your lattice energy. Yes. Plus delta H lattice energy. Okay. Now if I give you a question, the bond Haber cycle of KCl is evaluated with the following. Delta HF, delta heat of formation, is given to you, right? Minus 436.7 kilojoule per mole. Next is given delta sublimation H naught 89.2 kilojoule per mole. Delta ionization H naught equals to 419 kilojoule per mole. This is provided, okay. Delta electron affinity given to you minus 348.6 kilojoule per mole. Delta dissociation or bond is given 243 kilojoule per mole. So this, if you want to calculate delta HF, so over here we can write plus sublimation plus delta ionization H naught plus delta electron affinity H naught, because it is given minus, so why will you do minus, plus dissociation plus lattice energy. Now you have to calculate the following. KCl is evaluated with the following data. What will be the magnitude of lattice energy? You need to take out this. And now KCl, you remember, you doing KCl, so over here you are doing half dissociation to get Cl, so this dissociation you have to calculate half dissociation. Now put the values. So just put the values, use calculator, take out the value. I put the values, I got the value as this is the value. Okay, this was your sum from bond Haber. Thank you.